Hello, good afternoon. To this afternoon's webinar. The point of this webinar is it's just a short half-hour explanation of a tool called AsureSign that we've been driving. The point of showing it at this stage is because it's been in development for a couple of years and it's been working along with Infineon to drive it into a requirements engineering solution as well as a verification and test management solution. My name is Serrie Chapman. I've been working with the tool. I've now worked with TVS, who own the tool. And this afternoon, I just want to talk about the requirements engineering aspects of it, which is the parts that I've been driving. At a later point, we will be doing a full webinar so that we can see it in more detail. Right, so some of the history of this. I work, or have been working for the last 14 years with Infineon, which is an automotive microcontroller company. They also do chip card, and it's essentially a hardware company. So this has been driven primarily from the hardware perspective for us, and its background is with hardware. However, it is being extended into software currently. So a lot of the time when I use terms such as verification in the software world, it is test. When I talk about system on chip, that is normally your integration testing. So all of these terms are interchangeable. I've tried to make them as generic as possible, but apologies if it does still seem a bit hardware, as that is my background. Now, the thing with requirements engineering is normally in a lot of companies, some companies do try very hard to ensure that they do this very well, but in the hardware world, generally, it hasn't been taken as seriously, I would say, as in the software world. We have been looking at requirements engineering for quite some years, since 2004. However, back in 2011, in fact, prior to that, because we heard about it, there was a new standard brought out in automotive sector called the ISO 26262. Now, this actually mandates that you need requirements engineering, and I think it shook quite a few companies up because they suddenly had to go and find their requirements and put them into a proper controlled documentation manner and link them all together. And while we were looking at this, we implemented this first on a lead product. However, over time, that lead product has turned into multiple variants of the same, well, a similar product. So I now have 13 products with 80 modules in each, about 400 engineers. And we also have an issue where we have multiple test domains in hardware. In software, I know normally you do just have directed, but within the hardware, we have something called pseudo random, which is a constrained random type of verification. Then we have directed tests, we have formal, semi-formal. We then have validation, firmware and software. So in reality, it becomes quite an orthogonal challenge for us to ensure that we can reuse as much as possible. It doesn't cost us too much time, and that we also are aware of the differences. With regard to the variants, we're not the only company suffering here. I also work for two funding projects under Artemis. One is VTEST, which is looking at the ISO 26262 and documentation, etc. And the second is called Crystal, and this is looking at interoperability of the requirements in the product lifecycle. And we are currently investigating the best manner of working with the variants because it's quite a big issue. Right, so when we originally started with the requirements engineering, we went with what we thought was going to be the easiest way of doing it. So we got the requirements and we put them in a database. So we had a tool already in the company. The tool is actually being phased out and we are replacing it now. But not massive consideration was given to the quality of the requirements in that database. We also looked at the fact that we had things such as internal target specification that we also already had. We had legacy documentation. So we went with a tool that would allow us to keep our legacy documentation and then to link them all through. The tool is called Rectify, for any of you that were interested. The product requirement document was a new document for us, and we got that out of the requirements database. The safety concept was a new document for us, which is specifically for this standard, and that was handwritten. What we found when actually implementing this was that essentially your product requirement document became the top of our requirements tree. We then needed to match it to see how it was then refined, that requirement was implemented or refined through into the safety concept, if it was a safety requirement, or into the internal target specification. We then also needed to map somehow the internal target specification to the test plan to see how we were going to test it. And then we had a question of how we actually proved that we had actually implemented it. Now, one of the issues we did find is at any point of transfer, i.e. when you manually tag something, that the actual meaning of the requirement here might be corrupted. Apologies. Basically, it's because it's a manual process. You could take it out of context. If you put it somewhere else in a different hierarchy, it might have a different meaning. The other issue is that when we got down to the test plan, because we have these multiple domains and multiple ways of testing, we then had to translate that and somehow manually link that into the test plan, which was not a very good idea. It was very painful, and we're still struggling to get it finished. So from the first generation, which we found we had an awful lot of issues with moving data around, we came with a new tightly integrated requirements engineering and test flow. So the requirements this time were written down to feature level to be atomic, and that was a lot of overhead. But in reality, you do need quality requirements if you're going to manage a requirements engineering flow. Because they're at feature level, we can then extract these into an XML format, and we can import them so that these feature level requirements are essentially your test plan. You don't have to have this in a requirements engineering flow, and you could just manually put in your test plan. What AsureSign then does is it will translate all of the different types, which you give it the rules to say what pass-fail criteria is, how you recognize a pass-fail criteria. It then analyzes that, extracts the information, puts the results out in an XML format, so that for the requirements engineering flow, it's a simple pass-fail, so that's your coverage. So AsureSign is essentially for us doing a requirements-driven test methodology, which is quite new for us. We normally went with a normal test plan, handwritten, etc. So as I said, we import the requirements into AsureSign via XML, and this is essentially the test plan. From there, you can then refine it down. So essentially, your requirements become a feature set, and you can have sub-feature sets within the tool. The requirements import removes any data translation risk. You have the same hierarchy as the requirements engineering flow, and you have the same data because you've got it directly out from the other tools. Change management, any requirement change is visible. We have a flow that if we have a change in the requirements through our change management process, then we have a new XML, which we know we have to import back into AsureSign. This automatically will alert you to what tests or changes you need to make. The live database, before we found with documentation maintenance that people wouldn't necessarily update their test descriptions when they changed them, because to change the test description was an overhead during the life cycle of the project. So people would then have to go out and open a document somewhere and update it, and people didn't do that. So within the tool, you've got all the details of the test and the descriptions written in it, and the tool's live for you. So we find that you know quite early on, as soon as you're changing a test, it's quite easy to go into the database and change it. For audit proofing, the AsureSign is essentially a live database of information. At milestone times, we produce documentation directly out of it and put it under configuration management, so that essentially works as a snapshot for your auditing. Report tailoring, because we have selectable fields within the tool, we're able to select particular pieces of information that we want, and because it's all XML, we can translate that into whatever documentation you require. The next issue we had with requirements engineering was what we call the proof of implementation. So if you have a requirement, the most essential thing you need to do is ensure that, one, you've understood that requirement all the way throughout your flow, and that you can prove that you've implemented it and that it's working. So therefore, your proof of implementation is in your results. It might be that you justify certain things manually, or it could be that it's a simulation results. So once we've got the requirements into the top level of the AsureSign, the test engineers can review the requirements, and you might want to do several layers of hierarchy under this because you might have multiple ways of testing things. But within the tool, you can then make links in the hierarchy to the list of goals. So you have one requirement and you might have 5 tests or goals or metrics you need to match to ensure that that is complete and verified. Proof. There's different type of tests. So this tool actually works across the different types that we said before. So it will work with directed tests, random, assertional, formal properties. It's also been expanded to do GCUB and some more software, so we're expanding it more into the software world now. It will also allow you to manually verify and justify how a requirement was covered, such as, for example, you might point towards a waveform, etc. Flexible grading of tests. One of the issues that we always found is that within our project we have what's called IPs. They go into subsystems, which then go onto system on chips and get stuck together. In the software world, I believe it's called units and integration testing. But one of the, because of the fact that we have such a big product family, one of the things that was required of us was that we give an early release. So when the IP isn't quite ready or it hasn't been fully tested, they wanted it released early so they could start sticking it together. One of the issues with that, especially with Infineon, is we're a big company, we're multi-sites, so we were actually giving out IP from the Infineon UK site to our German Munich team. They were sticking it together, then they were testing things that we hadn't tested yet. So we were both debugging the same thing at the same time. What we can do is we can grade the tests. So one, this will give you a list of all the tests you want to do first. You can agree that with your integration team and say which ones do you want done first, and then they are aware not to test anything outside of the boundary of the ones that you've already tested, which should actually assist with over verification or multiple verification that you don't need to do. Reduce. So one of the things is currently within hardware, at least, we have things called checkers and coverage points, and we also have lots of tests. One of the things we want to do is to help maintenance. If we're maintaining a requirement or a test and there's no requirement that it's linked to, then we can take that out of our maintenance and take it out of our testing. We need to ensure that the tests are only being run that we really need to run. We know that we have over-engineered over the years due to legacy and picking up test benches that nobody had worked on before. Right, one of the issues now is because of the fact that the verification test engineers and the design engineers both get a set of requirements at the same time, what you can do is, rather than the test team can start a bit earlier working out how they're going to test everything, they don't have to wait on the specification arriving. But when they do arrive at the specification, they still have to turn around and see how the implementation is, as it may affect how they're testing. If, however, the test and specification for a certain requirement disagree about how it's implemented or how they thought it was going to be implemented, then that becomes an ambiguous requirement. If you get an ambiguous requirement, it needs to go back through change management system. If there's a test and no requirement, like we said, it could be an obsolete test or something that needs to be removed. It could, however, be a missing requirement. If it's a missing requirement, it should go through a change process and go back into the requirements list to give you a more complete set of requirements. Again, if there's a specification, so if there's something written in the specification that's a feature, and when the test team see it, they try to look and say, well, it doesn't fit to any of my requirements as I see it. That is, again, either a missing requirement, which needs to go back in through the change process, or it could be that the specification design engineer has decided to add a feature just because they wanted to. This is over-engineering and it costs us a lot of money. We can't afford to do it. If you put it through the change process, then we can say, do we need that feature, or do we not, and can you please take out the specification? We need to turn around and be a bit more lean about what we're actually implementing and testing. So the next part of it is how we linked the requirements to the proofs. So as I said, the proofs are in the results and in the metrics. So the requirements go down through the hierarchical flow, right down to the tests, coverage points, checkers, and formal properties. So you can choose a type, and then you do some mapping. The tool itself knows, once you explain what type you're looking for, it will give you up a list of all the options you can get, so you can just click on it. Automated analysis. We can configure the criteria, so it's a semi-automatic because you have to decide how to analyze the proofs and clarify pass-fail criteria. Within the hardware world, we have things such as coverage and checkers. We can say that we have at a certain milestone level that we need an 80% coverage to get through that milestone, and that we need 100% at a later point. So you can configure the criteria to suit yourselves. So although the tool is analysing and giving you the pass-fail, it's actually you to decide what that pass-fail criteria is. Integration into the requirements traceability flow. It does support multiple XML schema. Currently one of them is an Infineon one, which we are happy to donate out. And because of the fact that we have the schema, we can link it back into the flow for whichever schema you want. AsureSign has its own schema also. But this actually proves, once you've got down to the proof and once you've got these results, that actually gives you closure to your requirements traceability tree. Viewing. Because of the fact that we have all of these different types of testing, we wanted to view them because normally we have something such as formal requirements that are directed test and coverage, but however, we didn't know whether we had any overlap between those. Because of the fact we can now see across these multiple domains of testing, we should be able to see that if we've tested something in one type, in a formal test, for example, then we don't need to hit a coverage point in the random, so we can stop trying to overlap and do too much over-engineering on the verification and test side. One of the great things about it is because of the fact it automatically knows the type and you're just clicking on it, you don't need to tag. A lot of requirements engineering tools require that you go in and you manually put some marker inside the actual tests or inside the actual documentation. With AsureSign, you don't need to do that, which is very nice. Right, so that's the requirements engineering side of it and why we drove it in from Infineon. I'll just mention a few of the other features it supports. I no longer work in test or verification, so I don't have the biggest knowledge on that, but I do have a very, very good couple of colleagues who've been testing it quite savagely, I would say. So it does support multiple regressions and multiple tools. It's not a regression runner under its test management hat. It is a data analyzer, essentially. So you can compare regressions to see whether something suddenly went wrong, or you can track and analyze whether there's any trends. When you change specific parts, it affects particular areas, etc. For storage-wise, it's kept in MySQL database. You'd have one per product, and we keep these, we daily snapshot these, so that's for our storage. For security, it's password protected to different levels of security. So you have different access rights depending on what functionalities we allow you to have. Scalability, this is I find quite clever. We have an export-import solution which actually also links into the obsolescence. So we can export in XML and then we can re-import. So for each project you would export at the end if you wanted to reuse all of your tests, which actually allows you to keep all of your mapping. You can then turn around and change your requirements by doing a partial import. Partial import would just give you your top level. So everything will be saved except for anything new or anything old. And then because within the tool you can see whether that's mapped, you'll start to be able to work out that one, to manage your variance, you could take out a whole load of tests because you've automatically got a list of those now, or that you need to write some more tests or some more metrics. Because they're obviously missing their mapping. So this is quite useful. We should also be able to get out the difference. So you should actually be able to get a variant list from it and documentation, which in Infineon, I know that our customers ask us for quite a lot because our specifications are very, very large and they don't want to reread a whole specification each time. So this would be quite handy to at least show you your different features. It can also support multiple hierarchies. So if you exported from a small IP product, you could have a subsystem, for example, and you could import multiple ones of these and organize them however you want so that you have a subsystem list. Also with the export and import solution, you can do bulk edits. So you can go and delete whole swathes of stuff or add stuff quite quickly rather than doing it manually through the tool. Configuration management, it supports. So it does support ClearCase, so that's multiple fobs, etc., SVN, Git, and others, I believe. So I'm sorry it was brief and we missed 5 minutes of it. We did just about make it through. Towards the end of March, I believe the 20th of March, we're going to set up a further presentation of this tool. It's going to be a full 1 hour one, and we will show you a much more detailed presentation of the tool. So we'll talk you through the screenshots and explain how things work. So if you're interested in finding out some more about the tool, then please contact me. We will send out, I believe from Sarah, we will send out a link to where this slide set is. And we will also, I'll send out, as before with LinkedIn and via email, the invites to the next Eventbrite. So, Sarah, is there anything you'd like to add?
Hello, yes, we do have a question from Shahzad Anwar. He asks, does the tool also manage requirements or integrates with other RM tools?
Yes, we're currently, at the moment, most requirements management tools do support XML. The Crystal project that I'm working on currently is doing some more work on that. Currently, we're also discussing with Rectify. Rectify are going to give us a tight integration with their tool. The rest of it tends to be export-import via XML.
Lovely, thank you. We only had one question from, and another one's just come through, bear with me. It's from Johan, and are requirements connected with, example, FMEA database or fault trees?
It can be, yeah. There's no reason why not. We're using a DD analyzer at the moment for FMEGA. When you go outside of the tool, this tool more is for verification and test. But once you go outside of the tool, you can always use a tool such as Rectify to link those. But there's no reason why, if you can't get an XML out of your FMEGA or your FMEA and export that as an XML, we can always import it in, and you can use that within the tool itself.
Lovely.
So it's essentially yes.
Good. And another question from Shahzad. How does it show test coverage?
I think this is going to be for the next meeting. We have got a set of slides that I'm preparing for the next meeting, and that shows you on the interface how you see all of the various things. But yeah, it's got quite a nice dashboard to show all of these things.
Good. Thank you very much. And the last question from, and I apologise for pronunciation of your name, from Serrie. Would this link to FMEA be a one-way import or two-way interconnectivity?
Currently we haven't done it, but there's no reason why not. You could do it both ways. We've got an import-export round robin, and as long as the FMEA knows its XML schema, we can import and export quite easily. So it would be both ways.
Lovely. Thank you, Serrie. Appreciate that. Thanks ever so much for listening, and we hopefully will see you at the next one next month.